Today's lesson is the part 2 of the Pythagorean theorem. We are going to look more in depth at PPTs, which are primitive Pythagorean triples. So from the last one, triples, Pythagorean triples were a squared plus b squared equals c squared, where a, b, and c were all whole numbers. Today we're going to look at identifying PPTs using a PPT list to find missing sides of right triangles, and then our final step is transform sides of given right triangles into PPTs. Then we can use the list to find the missing side. So a PPT is a set of non-zero whole numbers a, b, and c so that they do not share a common factor other than 1. All right. The last one we looked at, we had 3, 4, and 5. 3, 4, and 5 is a PPT. 3 squared plus 4 squared equals 5 squared. They do not share a common factor. 6, 8, and 10 is still a Pythagorean triple, but it's not a PPT because they all have a common factor of 2. All right, so our list of common PPTs is here. The key thing to note, the last number listed is always the hypotenuse. On your assignment, I did put a copy of this list so that you have it for quick reference. All right, example 1. We are going to use the PPT list to find the missing sides of these triangles. All right, we have 9 and 40. So if we look at our list, 9, 40, 41, that side has to be 41. This gives us a nice little shortcut that saves you from having to do the Pythagorean theorem every time. If you still wanted to, you could do the Pythagorean theorem and don't have to worry about that. All right, next one. Hypotenuse is 37. One of the sides is 12. So if we look, we have a hypotenuse of 37. One side is 12, so the other side has to be 35. Makes it nice and quick for a couple of these. All right. Now, some side lengths can be transformed into PPTs by pulling out factors or multiplying to get rid of some decimals. So if we look at this example A, this is the same as 5 times 10. This is the same as 13 times 10. So this is going to be something times 10. All right, so if we look at our PPT list, there is a 5, 12, 13, where 13 is the hypotenuse. So this side is 12 times 10, which ends up being 120. So that side has to be 120. All right. All right, on this next one, if we multiply them all by 2, so 8 times 2 is 16. 31.5 times 2 is 63. So that means something times 2, 16, 63, 65 is our PPT. So divide both sides by 2, and we end up getting 32.5. So this side has to be 32.5. Again, if you wanted to, you could use the Pythagorean theorem and do it that way, but this does end up being a little bit quicker. All right, next example. 1.8, 2.4. We want to get rid of those decimals, so we will try by multiplying by 5. All right. Okay, so if we multiply this by 5, it gives us 12. Multiply this one by 5, it gives us 9. If we look on our PPT list, there's not one that has 9 and 12, but if we also recognize that they both have a common factor of 3, we can divide both of these by 3, and that'll give us 3, 4. So that makes this one have to be 5. But now we have to undo the process that we had before. So since we had to multiply by 5 and divide by 3, we are going to do it the other way. We are going to multiply by 3 and then divide by 5. So 5 times 3 is 15, divided by 5 is 3. So the final answer for this side, it has to be 3. And the last one, notice that these have a factor of the square root of 5, so we can pull that out. We have a 20, we have something times the square root of 5, and a 29. So 20, 21, 29. This side is 21 times the square root of 5. So this can be a shortcut to simplify some of these using the Pythagorean theorem. The next key idea is to be aware of the trap. Just because it looks like a PPT doesn't mean it is. The hypotenuse is always the number, the largest number, it's always the one on the end. So if we look at this one, it looks like it should be a 3, 4, 5, but since this is the hypotenuse, it cannot be 4. So we have to do this using the Pythagorean theorem. 3 squared plus 5 squared equals c squared. So 9 plus 25 equals c squared. Take the square root of both sides, and we get square root of 34 equals c. And that, we cannot reduce that one further. It does not have any perfect square multiples or factors. All right, part B. If we look, we can take out a factor of 100. This is the same as 41 times 100. This is the same as 40 times 100. But this side is not 9 times 100, even though 9 is part of a 40, 41 with 9 as the other leg. 41 has to be the hypotenuse. So we do know that this is something times 100. So we can pull that factor out and then figure out what that is and then multiply it back through. So we do our Pythagorean theorem. We're going to do 40 squared plus 41 squared equals c squared. So this gives us 1600 plus 1681 equals c squared. It's 3281. Take the square root of both sides, and c equals the square root of 3281. All right, this does not have any perfect square factors, so we can't simplify it further. We can take this, put it back in here, and it'll be 100 times square root of 3281. And that is the length of that side. All right, so your assignment is posted. Use the idea of PPTs to find the missing sides of those triangles given.